Greetings, folks. Joseph Kursky here with you to discuss some key GIS skill building exercises and some spatial thinking perspectives through a course that I'm teaching through Aussable Institute of Environmental Studies. Now, you don't have to be in that course to go through this lesson, but in this lesson, I will describe it for you. You will add a layer. You're going to go to ArcGIS Online Map Viewer. You're going to add a layer pointing to a feature service that I actually got from the U.S. Geological Survey that indicates zebra mussels over a span of about 20 years. Take a look at this, figure out as best you can based on eyeballing it, but we'll do some spatial analysis in a bit, where these mussels came from, how they spread, why they're spreading, and what we can do about it. Do some additional research to figure out what we can do about it. So you see the spatial pattern over time. Let's go ahead and filter the data. That's a powerful, often used technique inside of GIS. Let's add a filter in the ArcGIS Online Map Viewer. Let's go ahead and say, I want the locality to be a certain position, a certain point where the zebra mussels were sighted, and that is the Des Plaines River outside of Joliet, Illinois. So I'm going to paste that inquiry here in the locality is. Okay, let's go ahead and do that. Now, what I like about the map viewer is that instantly you see the result in that dark red spot, the unfiltered data. The data that's not filtered is actually in gray. And now I'm going to add an expression, as you can see here. I want the year to be 1991. So the Des Plaines River outside of Joliet, and the year being 1991. I see instant gratification. I see the point, and if I say done, I only see that point because that's what I'm filtering on. The full data set is still there, but I'm only filtering on this one point, so that's all I see. And just to verify, I always say, don't just click, click, click and accept these results. Go ahead and investigate. Spend a few minutes to verify that those are the results that you expected. Okay, so we have that one zebra mussel from 1991 outside of Joliet at the Des Plaines River. Now I'm going to go ahead and see about another layer that I could add in here, and that is the World Hydro. There's a variety of data sets, but what I want is the ESRI Hydro Reference Overlay. Let's go ahead and add that one in. This is a wonderful, scalable world hydrographic layer. As you scroll out, you see major rivers like the Amazon, the Yangtze, the Nile, etc. As you zoom in, you see tributaries. You even see in the USA watershed boundaries with those little black dotted lines showing. Okay, so now we have a hydro. Why are we using the hydro? Because these zebra mussels travel by water. They can't pick up, they don't have any legs. They can't pick themselves up and walk. They can't hitch a ride on trains. So they have to migrate by water. And so that's an important layer for us to analyze here in our lesson. So let's go ahead and look at the analysis tools inside ArcGIS Online. Let's do a trace downstream. So if I wanted to figure out how these zebra mussels might be able to get from the Des Plaines River to other tributaries and rivers here in North America, a trace downstream might be helpful. Now, sometimes these actually get into cavities of boats and they're transported across land to another reservoir or lake or river. That's why you see these warning signs at state parks and other places where please empty your boat of all water. So these zebra mussels, which might be trapped in those water cavities, can't migrate and displace other species, which is the main problem that these things pose. They proliferate. And so let's go ahead and do a trace downstream, 5,000 miles. Let's give it a meaningful output name. And what we're going to do is we're going to get a sense then, based on this analysis that uses the underlying hydro layer and the elevation, etc., what the water would do if it was a cup of water was poured at the Des Plaines River right there where the zebra mussels were sighted. We're going to go ahead and calculate that trace downstream. We'll give it a moment to run. Now that it's run, let's change the style for that new trace downstream layer. Let's make it thick and a bright blue so we can distinguish it from the rest of the World Hydro layer. Bump up that width a little bit using change styles or change symbology. Now we really see from the point at which we ran the trace downstream all the way down the Des Plaines River, all the way to the Mississippi River on down to the Gulf of Mexico. All right, let's look at the table of data that we've got there. It looks like it's about 1,477. What units are those? It's always important to analyze the units. We said in miles, so that's in miles. Okay, So we've got a table of data just like we do for most other layers inside our GIS. We can analyze that for further information. That's super. Let's go ahead and proceed to the next step of the analysis now. We have our trace downstream, we have our zebra mussels, and let's go ahead and just double check the measurement. I always like to do this to make sure that your results are what you thought it would be. If we just kind of generally sketch along here, we're going to get something close to 1,400 or so miles. And we're omitting all the bends in the river, so we're not going to be exactly at 1,400. We're going to be at 1,200 or so, and that's good enough to know that that tool ran successfully, and now we're ready for the next step. Let's go ahead and use the filter tool again. Some of these layers on the left are nested layers, so you need to pay attention to which inside nested layer you're paying attention to. In a GIS, most functions, labeling, filtering, symbology, etc., operate on the selected layer, so you need to know what layer you're on. So let's go ahead and make sure that our zebra mussels are selected, and we're going to say, look at the histogram here. I love the instantaneous results you get from looking at the spread of the data in the histogram. The year is less than 1995. Okay, let's go ahead and save that. Now I see that it's mostly clustered over the Great Lakes, some of the Ohio River, Tennessee River, etc. Now we only have 1,753 records of our original, more than that, thousands more, zebra mussels selected. So we're also going to look at the table and make sure that the year is only up until 1994, right before 1995. So just a couple of double checks to make sure that your results are what you expected. Let's take a look at now. Our trace downstream is there, but we want to go to another analysis tool now. Let's go ahead and do the following. Let's calculate a mean center and a standard deviational ellipse. If I type in mean center, that's not the name of the tool. So it's important to know the names of these tools oftentimes. You can do a search, but summarize, center, and dispersion, inside of which is a mean center and dispersion. So summarize, center, and dispersion. We want a standard deviational ellipse, and we want a mean center. So we're going to uncheck a couple of those other things in there. All right, so our standard deviational ellipse, in other words, one standard deviation in space now from that mean center is going to be our result. One standard deviation from that center, and we're going to get an ellipse around that. Sort of like a standard deviation around a statistical set of data, but here we're using it in a spatial context. Give your output name a meaningful title, and go ahead and run that tool. Looks like I need to re-specify my input layer, which is my zebra mussels layer. So make sure that you specify you want the standard deviational ellipse and the mean center before 1995. You're filtering on that, and that is your result right there. It's got an ellipse, it's got a mean center, and we're going to go ahead and change the symbology for the mean center and the standard deviational ellipse so that they're the same color, so that I can visually look at that and say, oh, that's before 1995. Again, some of these things inside of your GIS, they're guidelines. They're not hard and fast rules. You don't have to do it this way. But GIS and the world as a whole is complicated enough. Don't make it more complicated. Make things easy for you and your data users, your map users, to understand what you're doing. So that's one of the reasons why I'm changing both of those things to green here, so that I can easily see that, oh, okay, I've got the mean center for pre-1995 in green. I'm going to change the standard deviational ellipse to the same color. Notice that my last color is right there, so I can go ahead and do that. If I select it here, it's going to give it a fill, and I don't really want to fill it. I want to see the features underneath it. So now I've got the mean center and the standard deviational ellipse pre-1995 zebra mussels data in green. Now we're going to, as you probably suspect, repeat the process for 1995 and later. Now it's important to know the breakpoints. So understand your data. You don't want to have an overlap, and you don't want to say 1995 and before, and then in your next query say 1995 and after, because you're going to double count 1995. So be careful on your breakpoints. It's all a part of being critical of the data and understanding your data and where it came from, who updated it, how often it was updated, all that sort of thing that I'm always stressing. Understand your data. Okay, so now we have a filter of the 1995 and after. So I'm sorting on year, making sure I have that correctly filtered. And now we're going to go to analysis once again. We're going to calculate the mean center and standard deviational ellipse and give it a meaningful name that's different from the meaningful name that we assigned earlier. This time post 1995 and later. Okay, very good. We could estimate credits if we wanted to. We're going to go ahead and run that. We can view the status of our inquiry. It's important not to over-click here. Make sure that thing runs. You can see the little blue point to the right of the clock in the upper right there. While it's running, it will be blue because it's in progress. So now I'm going to go ahead, once that's done, it's done now, I'm going to go ahead and change it to a different color. I think I'll pick orange for the 1995 and later. You could put in the hex bin number here for the colors, the CMYK, etc. if you want to. I'm just going to go ahead and pick it from the palette here. I'm not going to fill it. I'm going to make the outline color orange and go ahead and make sure that you're operating on the correct layer at all times. Again, no color for the fill, the outline color in orange, and now I've got the 1995 and later zebra mussel distribution in orange. And now, more importantly than running the tools, is to understand, well, what are the results? Now I can see if I toggle these on and off, I can see that the standard deviational ellipse was really more focused on the Great Lakes pre-1995, and then 1995 and later it expanded. It got wider and a little bit narrower, but it expanded because the zebra mussels themselves were expanding. So it also shifted a little bit to the west-southwest as these zebra mussels unfortunately made their way down these waterways of the Ohio and the Mississippi and even the Missouri River watershed. So now I've got 2 mean centered layers and 2 standard deviational ellipse layers. Another enhancement is I could actually label the mean center. So if I'm sharing this map with others, they'll understand what I've got here without having to go to my layer list on the left and identify it that way. So I'm going to go ahead and click on this expression here and label the feature with the label, just a text label, that says I want, in quotes, mean center before 1995. Go ahead and say done there. That's looking good. And then I can do the same thing for the labels, for the label of the mean center post 1995. I'm also going to color this the same way as my mean center feature itself and also my standard deviational ellipse. Again, to foster understanding for this is what it is. You can see here you've got a lot of flexibility. I think I'm going to make it bold and italic. Let's do the same thing for our labels post 1995. Go to the expression builder, erase what's there. 1995 and later, that looks good. Make it the same font, try to match the color. Again, I could put the hex bin number in there if I wish, or the CMYK, HSV, RGB colors. Lots of flexibility here. I'm going to make it a halo because that orange is a little bit light. If I don't put a halo around it, it's going to be really hard to see on the map. So I'm going to do a little halo here. I'm also going to offset these things. Notice the offset tool. I'm going to offset this to the southwest of the point itself, and then I'm going to go ahead and offset the mean center before 1995 a little bit to the northeast of that point. Remember what layer you're examining. I'm going to go ahead and change that. The goal is not to make a perfect map here. I could spend more time on this, and you're free and welcome to do so. Spend a little time with the metadata. Make sure that your metadata here, your title, your tags, your summary is meaningful, so that if you share this with others, they'll understand what you did and what these layers mean. Super. Now I have the mean and the standard deviational ellipse for 2 different time periods, so now I have a better understanding of how these zebra mussels changed over space and time, which was our major goal for that part of the lesson. Let's proceed and dig a little deeper now. Expanding our GIS skills. Let's show the table of data for the ellipse layers. Notice that I do not have any sort of indication of how large these are, these ellipses. I can eyeball it, and I can also use the measure tool. Some distance units here for the focal point and the flattening of the ellipse, but I don't really have a field indicating how large it is. How do we do that? How do we find that out? What I really want to do is I want to add a field and then calculate that field based on the geometry, how large that is. How do we do that? We have to go over to ArcGIS Online into your content area. Click on the three lines on the upper left, go to Content, and go into the folder where your content is located for this particular lesson. You'll see a variety of maps and layers there. Go to the feature layer hosted for your mean center and standard deviational ellipse. Once you find it, go to the item information page or the metadata page for that layer. Go to the data tab. It's a nested layer, so make sure on the upper left you click on the ellipse layer. And now what you want to do is you want to add a field, name it appropriately, area square kilometers. It's going to be double precision. I'm going to add a new field there. Verify that it's added. Click on that field, go to Table, go to that field name, and click on the field name, calculate it using Arcade. It'll bounce you to the Arcade Expression Builder, which we've seen before with labeling, right folks? And here is where you're going to use a combination of functions and globals. And don't worry if, like me, you don't click on the right thing first. You'll eventually get there, because what you want is for the area in square kilometers to be populated. So the area function is what you want. The globals, you want to be able to have $ feature in there because that's using the geometry. So you can see there that this syntax is wrong, so I'm going to need to erase features without the $ before you can see what the arguments are supposed to be. Area, bracket, curve paren, features, and then the unit. My unit is going to be square kilometers. This has to be typed exactly like that, with a dash between the square and the kilometers, because that is a function that it's getting. Now I can go ahead and erase that other stuff, and I need a close bracket there. And that looks good. Let's go ahead and say OK there. So it's basically going to calculate the area in square kilometers and put it in the field name there for area square kilometers. So it's calculating it based on the geometry. Of course, the map projection makes a big influence on this, and we can have a separate discussion on that. It's 1.1 million square kilometers, according to what it's calculating. Remember, this is all cast in Web Mercator, so again, we got to be a little bit suspicious of the total, but we're not spending time putting this in Albers equal area or the U.S. state plane coordinates. We're leaving it as a default. So let's go ahead and open that map now in the map viewer. Let's click on the layer that we've identified. We're going to go ahead and drill down to the sublayer, which is the ellipse, the nested layer, the ellipse layer. Let's take a look at that table of data with the triple dots to the right of the layer there. Open the table, or show table, and we'll scroll over, and there is our area in square kilometers at 1.1 million square kilometers. Again, let's test it. Use the measure tools and roughly draw a boundary around it. If you're at 10 million or 100,000, you know that you're way off. So it's got to be close to 1-ish million square kilometers. I'm just going to roughly sketch around this, just to, again, verify that the calculation worked correctly. I'm going to double click in there. I've got square miles, so I'm going to go ahead and change the unit here to square kilometers. I've got 1.4 million because I'm a little bit larger than the actual ellipse, but I'm close. So I know that the calculation worked, and I can go ahead and show table here as well. So that is the method of going to ArcGIS Online and going to content. One of the things that rolled out in June 2024 is you can actually, for selected features, selected layers, you can actually go ahead and add a field name and calculate it right inside the map viewer, which allows you to bypass the rather cumbersome, admittedly, steps of going out to your content area, going to the data tab, etc. You can actually do it for certain layers inside the map viewer. So you might want to tinker with that method and take a look at the What's New in ArcGIS Online June 2024 for that particular new function in there. But either way, we've calculated the area in square square kilometer so we could compare the pre-1995 with the 1995 and later, see what the square kilometer value was for each of those 2 years, and further understand the spread and distribution of the zebra mussels. So let's go ahead and save because we've done some work to our map. It's always a good idea to save. Some of the tech tools inside ArcGIS Online have an autosave and some of them do not. So it's important to pay attention to which have an autosave and which do not. It's asking me, hey, Joseph, you've got some layers inside your map that are not shared. So if you're going to share this with everyone, you need to share the layers inside as well so they don't get an error. Now I'm going to go to the lower left and say create an app. I'm going to create a story map right now from it so I can more richly tell the story of the zebra mussels change over space and time and why it actually matters and why we should care about invasive species like zebra mussels. So I'm going to give it a title. The map that I've just worked on is inside there. So notice that because I only had a couple layers turned on, that story map, which is feeding the map from ArcGIS Online, only has a few things on. So I can go ahead and change it here inside my map. I can turn on those layers so that when I go back to my story map, I'm going to save this map again, I'm going to have to refresh. I can't just do a standard refresh here though. I'm going to need to add the map in again. How do I do that? I can go ahead and delete, just with the trash bucket there, delete that map, and then I can go ahead and add it again from a map and point to my map inside my content in ArcGIS Online. It'll be the last version that I saved. I'm going to go ahead and save this now, and now I see my more full map inside there. I've got the mean center and before and after 1995. I also have just one standard deviational ellipse, don't I? So I'm going to update sharing there, and I'm going to go back to my map one more time and turn on that all those layers because it looks like I missed one. So I want to make sure they're all on, but I also want to point out something else to you right here. Save that map again. Let's go ahead and use our procedures of deleting the old one and adding the refreshed updated map right here. Notice right here though, you can actually turn on and turn off layers right inside when you're placing that map. So there's really no need to go back to the map and resave it like I did. You can actually turn on and turn off layers right here. Okay, that's great. I've got the mean center before and after 1995, the standard deviational ellipse, the zebra mussels, the trace downstream, and the Esri World Hydro. So it gives me a better sense, now once I start fleshing out the text and other things in my story map, of why these things moved, how they've changed over space and time, and what we can do about it. Thanks for being with me.